This is Higher Maths, it's practice paper D, and we're working here on question 3 in the calculator paper. Okay, security guards are watching a parked car via 2 CCTV cameras in a supermarket car park. With reference to a suitable set of axes, the car is at 532, so the car's sitting here, and the cameras are positioned here, and there's the three 3D coordinates of each of these. Right, so we have to calculate the size of angle ACB, so that's ACB. Okay, so no clues on how to really start it. We've got a little bit of a help here by, I can see 2 arrows that are pointing away from the vertex, and really that's something that's really important to make sure that we do here when we're trying to work out the angle that's in here. We must know the vectors that are pointing away from the angle that we're trying to find, or from that vertex there. Right, so let's find the components of vector CA first of all. So I've got vector CA, and what I'll do with that is I'll work out the position vector for A, take away the position vector for C, and just set that up. So that'll be -164, subtract from that C, and that's going to be 532. And just subtracting that should give me -632 as the components of vector CA. Let's now do CB. And just set it up the same way. Okay, I know that's going to be the same there, so I'll fire that in there. And then what we're looking at is for B, 795. 795 there, and do the subtraction, so it'll be 2, 6 and 3. Okay, so that's the 2 of them complete, and what we'll do now is we'll set up the angle to try and work this out. Now I just do this all in the one calculation. You may have been taught to do it separately. I'm just going to do it all together. So what we're going to do is we're going to look at the formula sheet, and we'll try and look and see how we're going to work out the angle and use the formula that's in there. You may have to change that formula around a little bit, but certainly you can get it from there. Right, so what we're going to do is we're going to get the dot product of both of these 2 vectors that are here. So that's going to be CA, and we've got CB. Dot product, or the scalar product. That's all going to be divided by the magnitude of CA and the magnitude of CB. Right, let's put our values in now, and for this dot product at the top we're going to multiply these components together, the x components first, so that's going to be -6 times 2, so that's -6 times a 2. I'm going to add to that the 3 times the 6, and I'm going to add to that the 2 times the 3, and I'll gather that all up for the numerator of this one here. I'll then take the magnitude of CA, so it's going to be -6 squared plus 3 squared plus 2 squared. So I'll get -6 squared plus 3 squared plus 2 squared. And the magnitude of CB, and again that's going to be 2 squared plus 6 squared plus 3 squared. Okay, if I work this out on the top, I've got a calculator, so we could use a calculator or you could just work it through. So that's going to give me -12. -12 plus 18 gives me 6. 6 plus 6 will give me 12 on the top line there. On the bottom here I've got, so -6 squared is going to be 36. 36 plus 9 plus 4, that will give me square root of 49. And on the bottom 4 plus 36 is 40, 40 plus 9 will give me 49 as well. So I've got 49 times 49, the roots, so that should give me 12 all over 49. That's there. So to work out the angle, all I need to do then from there, angle ACB, I'll just take the inverse cosine of the 12 over 49, and from there putting it into the calculator, and that should work out to be, let's see, 49, so that there would be 75.82. Okay, so 75.824 degrees, and I'll just round that to 1 decimal place. That'll be 75.8 degrees to 1 decimal place. That'll be the question complete. Okay, marking for this one here. So 7 marks in total for this. What we'll do is we'll get 1 mark for working out the components of CA, 1 for the components of CB. I'm going to give 1 for setting up the equation here correctly, the formula for working out the angles ACB. I'll go for 1 mark for getting the scalar product, the top line there, and 1 mark for each of these. So we'll go for that and that. It could be 7 and 7 to give us the 49. And finally, I think we'll go for 1 mark for the final answer. So that'll be 1, 2, 3, 4, 5, 6, 7. So that's out of 7 marks.